For studying rough weather, the National Weather Center in Norman, Oklahoma is at the center of the action. Inside, researchers are working on what is called the Hazardous Weather Testbed. Participants work with the latest computer models and cutting-edge forecasting techniques.
It's about bringing practitioners or operational forecasters together with researchers and computer modelers, a very broad community, and bringing them all together to focus on the next generation of weather prediction.
Typical workdays start after noon. It's taken all morning for the sun to heat the atmosphere. Warm air rises, and rising air mixes it up. That churning air is what provokes severe weather, and that's what these experts are studying. They're also getting ready for the future. A brand new NOAA weather satellite is on the horizon. Once launched, it will take its place in space and offer a wealth of major new capabilities.
GOES-R is going to be unbelievably helpful, whether it be lightning data or cloud. We're going to have so many more different channels in terms of visible or infrared that will help us in terms of forecasting and figuring out where that severe weather is going to happen.
GOES-R may be the latest in a long line of satellites, but its new capabilities will be more than just a tune-up.
So it's going to be like putting on glasses compared to what we have today. So this is going to be a great improvement to our methods right now.
Rough weather used to be the great unknown, something always over the horizon and capable of arrival without warning. But times are changing, and with hands-on training like that of the Hazardous Weather Testbed and new technology like GOES-R, forecasting will continue to develop into one of the only disciplines that can actually foretell the future.
South Oklahoma City, it'd be big hail and lightning would be my biggest concern.
After all, knowing tomorrow's weather profoundly affects decisions today.
Between analyzing urgent weather data and effectively communicating important weather threats to the public, National Weather Service forecasters have a lot on their plate.
whether it comes to severe weather or maybe a larger scale event like a winter event. You want to give as much lead time as possible and also be as accurate as possible. And that can be one of the biggest challenges in terms of forecasting.
To help improve performance, researchers develop new and exciting tools and techniques for the forecaster. But will it actually be helpful? Will a new feature increase efficiency, or will it hinder the process? The only way to know for sure is to test it.
Here in NOAA's Hazardous Weather Testbed, researchers and forecasters from across the country and around the world come together to sit side by side and solve forecasting problems.
So once a new weather tool gets the stamp of approval, it can then be transitioned for use in the National Weather Service. The testbed helps speed up this transition.
This is okay.
What we do in the Hazardous Weather Testbed ultimately benefits the public by improving the forecasts and warnings that people receive when severe weather threatens.
For more information on NOAA's Hazardous Weather Testbed, check us out online and follow us on Facebook and Twitter.
Well, with tornado formation or tornadogenesis, what we're finding and what other people are finding is that you might have a rotational lock, but it's a rather weak rotation. And what's the characteristics of the surface are the important elements that trigger tornadogenesis. That could be topography, that could be variations in surface roughness, or it could just be surface roughness itself. And what we're finding is that circulation, weak circulation might be aloft, but what happens is the formation of a tornado occurs down in the lower several hundred meters of the atmosphere and then builds upwards. So according to that research, tornadoes don't really touch down and lift off. A better terminology would be tornadoes form down at low levels and dissipate at low levels.